Let us look at solving simultaneous linear equations. In the previous session, we ended up with this. Remember, a student buys 11 pens and pencils for 43 of whatever currency. A pen costs 5 and a pencil costs 3. These simple statements can be written as the following pair of simultaneous linear equations. So let x equal to the number of pens, y equal to the number of pencils. Then x plus y is equal to 11. That is, number of pens plus number of pencils is equal to 11. 5 times x plus 3 times y is equal to 43. So we had arrived at this system of linear equations. The solution will tell us how many pens and how many pencils did the student buy. Now we didn't actually solve it. So now we are going to see how we can solve simultaneous linear equations. So we have the first equation, x plus y equal to 11, 5x plus 3y equal to 43. This is a system of two linear equations in two variables. Now, can we convert it into a single equation in one variable? Yes. If we can eliminate either x or y terms. Now, how do we do that? Notice that the second equation has 5 times the x in the first equation. Now, if we can equalize the coefficients of x, we can eliminate by subtracting one equation from the other. So let's do that. X plus y equal to 11. We multiply this equation by 5. We get 5x plus 5y is equal to 55. Now the graph of this linear equation, that is 5x plus 5y equal to 55, is coincident with the graph of x plus y equal to 11. Since, as in the previous session we saw, if the ratios of the coefficients of x and y and the constant are in the same ratio, then the equations are, or the graph of those equations are coincident. So now we have the system as 5x plus 5y equal to 55, 5x plus 3y equal to 43. So now if we subtract one equation from the other, what happens? 5x and 5x cancel out. So we have 5y equal to 55 and minus 3y equal to minus 43. So when we subtract it, what happens? 5y minus 3y equal to 2y, 55 minus 43 equal to 12. So 2y by 2 equal to 12 by 2. We divide both sides by 2. We get y is equal to 2. We have found y is equal to 2. Substitute this value in either of the original equations and solve for x. We get x plus 2 equal to 11, which means x equal to 11 minus 2, which is equal to 9. So the student bought 9 pens and 2 pencils. Now it is very, very essential to verify whether our answer is correct or not. So how do we verify? Take the first equation and substitute the values of x and y. We get 9 plus 2 equal to 11. So done. That means the solution satisfies the first equation. But it should also satisfy the second equation. What happens? We have second equation as 5x plus 3y equal to 43. Substitute the values of x and y. We get 5 times 9 plus 3 times 2 equal to 43. So let's simplify the left hand side. 9 5 is 45 plus 3 times 2 6 is equal to 43. But we have ended up with 51 is equal to 43. That means our solution is wrong. So which means we have to go back and go step by step and see where we made a mistake. And we realize that in this step, 2y by 2 equal to 12 by 2, we should have arrived at y is equal to 6. not y is equal to 2. So which means this entire part is wrong. So we continue from this point onwards. So x is equal to 11 minus 6, which is equal to 5. So the student bought 5 pens and 6 pens. Now let's verify it again. 5 plus 6 equal to 11. It satisfies the first equation. 5 times 5 plus 3 times 6 equal to 43, which is 25 plus 18 equal to 43, which is 43 equal to 43. So that means our solution is correct. So we have solved the problem that we started off with. So x1, y1 is 5, 6. Now, remember we started off with trying to eliminate which one? We eliminated x. Now let's eliminate y. Notice that the second equation has 3 times the y in the first equation. So if we can equalize the coefficients of y, we can eliminate by subtracting one equation from the other. So x plus y equal to 11. Now this time we multiply it by 3. So we get 3x plus 3y equal to 33. And again, the graph of this linear equation is coincident with the graph of x plus y equal to 11. Since the coefficients of x and y and the constants, they are all in the same proportion. So now we have the system as 3x plus 3y equal to 33, 5x plus 3y equal to 43. Now let's subtract one from the other. Subtracting it, we get minus 2x is equal to minus 10. Now we divide both sides by minus 2. We get x equal to 5. So we have found x equal to 5. Now we substitute this value in either of the original equations and solve for y. So 5 plus y equal to 11. So y is equal to 6. So the student bought 5 pens and 6 pencils. Again, verification is very, very important. So x plus y equal to 11. 5 plus 6 equal to 11. So the solution satisfies the first equation. Now what about the second equation? Substituting the values of x and y, we get 5 times 5 plus 3 times 6 equal to 43, which is 43 equal to 43. So the answer is verified. Now let's look at it graphically. X plus y equal to 11. If we graph it, we get this line. And 5x plus 3y equal to 43. The graph is this line. Now what is the intersection point? Is this, which is nothing but 5, 6, which is what we had, 5 and 6. So we have solved this equation or system of linear equations algebraically and graphically as well. Plus, very importantly, we have seen how to verify these solutions. And remember, we can choose to eliminate either x or y to solve this system of equations. This method of solving system of linear equations is called elimination method. That's it for now. Bye.